Hi, I'm Kelly Carter, and I'm going to be doing a reassessment on point particles. The question reads, point charges of -5 nanocoulombs, microcoulombs, plus 3 microcoulombs, and plus 5 microcoulombs are located along the x-axis at x equals -1 centimeters, x equals 0 centimeters, and x equals 1 centimeter respectively. Calculate the electric field at x equals 3 centimeters and at 15 centimeters. So here is a nice little outline of drawing out the particles and their distances. The charges and their distances. And so first we must find R. In order to find R, we had to subtract the position that the charge was at according to the position that we were trying to observe. So here you had 0 and 0, which are vectors, and you had 3 minus the -1, which gave you 4, and so forth with the rest of the charges. So we're going to use the equation for electric field, which is 1 over 4 pi epsilon naught times q over r squared times r hat. Okay, so our 1 over 4 pi epsilon naught is simply a constant, and that's here. Okay, and our charge for the particle is given, and that's -5 microcoulombs, and so that's -5 times 10 to the -10 coulombs. And so you have to find the magnitude of R, which is simply 0.04 meters squared, and you multiply it times R hat, which is 010. You do that for each of the charges, and you get your answers. And here I forgot to multiply. I forgot to actually take the charges from centimeters to meters when I did my answer. So I made up for it here by multiplying times 10 to the fourth, because a centimeter squared equals 1,000 meters squared. 1 meter squared equals 1,000 centimeters squared. And so our final answer is 1.1 times 10 to the 8th. Now we determine what is the electric field when the particle is at a location that's 15 centimeters away. So you find your R again, which will be, for the first one, you have 0 because we have no x component, and 0 here because we have no z component. So you have 15 minus the -1, which gives you 16. And 15 minus 0, which will give you 15, and 15 minus 1, which is 14. So you multiply times your constant, 1 over 4 pi epsilon naught, and you multiply by each one of your charges. I'll do this charge this time. And so your charge is given, which is 3 microcoulombs, which will be 3 times 10 to the -6 coulombs over um, the magnitude of R. And so here the magnitude of R is 0.15 meters, and then you have to square it along with your R hat, which is 010. So once you find the electric field of all the charges, you find the net electric field by adding all of them up. So you have -1.8 plus 1.2 plus 2.3 times 10 to the -6 times 10 to the 6, and you get 1.7 times 10 to the 6 nanocoulombs. And we can determine that this is correct because the further you get away from charges, the electric field decreases. So we can see from 1.1 times 10 to the 8 to 1.7 times 10 to the 6, the electric field is decreasing.